Oh, hi, everyone. Uh, Next up, we have Patrick Smyth and Srishti Hegde from ChainGuard. They're here to talk about Cheese Must Stand, defending the Python library ecosystem in 2025.
So hey folks, we're going to be talking a little bit about supply chain security today. I hope you like memes because this deck is almost entirely memes, so just giving you a warning at the top. And before we move on from this slide, I just wanted to call out a very cool intern that we have, Michelle McAvity, created this art for us. So we gotta protect the cheese, okay? All right. So Srishti, do you want to introduce us?
Hi all, I'm Srishti. I'm a software engineer at ChainGuard. I work mostly on building and securing container images, and yeah, I'm based out of Seattle.
And I'm Patrick Smyth. I'm a Queens native, still live in Queens, and I'm staff developer relations engineer at ChainGuard. And when I'm hanging out with my wife and my little daughter Lily, I like to sit in frozen lakes and do sauna and stuff. I'm one of those guys. So, all right. So we are going to talk a little supply chain security. We're going to talk a little PyPI. But first, let's go but do a little ancient history. So like I started doing Python in 2014. I know some of you are like, oh, that was just yesterday. Some of you are like, yep, that does sound like ancient history. Just don't worry too much. This is the only cheese shop reference we have in this deck. But back then, we're going to talk about some problems that we have now in 2025. But we had some problems back in 2014 as well. People were still figuring out, oh, if I start a new project, should it be Python 2 or Python 3? It was before, so Python ecosystem got some serious recognition in the form of like an ACM award for Project Jupyter, which was a big milestone that I remember. And it was before PyPI in 2018 moved from beta to production and adopted the warehouse project. So there was a lot that changed. And one of the things that I like to think about and that we don't have to worry about anymore, I don't have to deal with, is the C-style string formatting. I don't know if anyone ever remember this, also like %s and whatever, tuple. But we've moved on from that, and the pain is behind us, thankfully. So we're going to talk a little bit about supply chain security. We're going to talk a little bit about PyPI. But when I was researching this talk and I was going back reading some PEPs, as you do, just sitting on the train reading some PEPs, and I saw PEP 301 had they said, oh, we should make this public package index, PyPI. And as prior art, let's look at some other package indexes. So there was CPAN, and there was one that I'd never heard of. It's called Vaults of Parnassus. And I was like, that sounds mysterious. And apparently, that's the great web design that they had back then. But it was a kind of a cool website and a little bit eccentric. They said like, in the dark caverns of the Vaults of Parnassus, you will find Python code with torch and candle in hand. Good hunting to all tonight, or whatever. And it was a pretty eccentric website, and a little different from what we have today. And it was named after Apollo killing the great snake Python. So if we ever have any, Python games or whatever, we need to call it the Pythic games or whatever, like Greek mythology after this, I think. But what we've lost in sort of eccentricity or whatever in the Python ecosystem, we've gained in modern infrastructure. And today we're very lucky to have PyPI. It's a public index. It hosts over 630,000 projects. 1.6 billion with a B daily downloads. That's a lot of downloads. And hosts almost 28 terabytes of packages, files. Actually, probably these numbers are even bigger because I just pulled this last week. But we're going to talk about some problems. So there's something rotten in the state of software. And this isn't a Python thing necessarily. This isn't a PyPI thing. But the environment, and actually this is from Hamlet 2000, which is actually a great version of Hamlet if anyone likes that kind of thing. But the environment has become much more adverse in almost every kind of public index. Okay, and some of you might have heard those concepts of the eternal September, right? That we go from kind of a low trust internet or a low trust community or rather a high trust community to a low trust community where there's a much more adverse environment. And there's a couple of things converging right now. It's affecting a lot of ecosystems. It's not just Python. But on the one hand, there is sort of this like background radiation of spam, typosquatting, Now slop squatting, where people are using AI to post spam to public indexes. On the other hand, you have things like very sophisticated supply chain attackers that are jumping in and targeting specific libraries so that they can attack people downstream. And then on the other hand, Python it's not 2000, it's not 2007, it's not 2014, it's not even 2020. Python is being used in all sorts of very high sensitivity areas. So it's being used in banking, it's being used in hospitals, it's being used by the government or various governments. And so it's not, we're now in this very difficult environment that PyPI has to deal with. So we're not all born knowing about software supply chain security. Like, what am I even talking about when I talk about supply chain security? I didn't know, have used Python for a long time. I didn't really know much about it until I started contributing to the SIG4 project a few years ago. But supply chain security, what is a supply chain? In the physical supply chain, it is a system that takes raw materials and over many steps and many actors, it produces a finished product. In software, we sort of use this analogy, so it's the software supply chain. And I think we all know intellectually, or maybe not all of us, but like many of us know intellectually that when we pip install something, when we pull something in as a dependency, it doesn't necessarily, it's not just that one thing. It pulls in many dependencies that are used by that dependency that we're installing, and then those dependencies themselves have more dependencies, so transitive dependencies. So this conspiracy runs deep, when you realize this. I think on a deeper level, you realize that when you pip install something, you're actually pulling in this entire graph, like mini ecosystem of dependencies, and that has serious implications. So unfortunately, there are many places where a sort of modern supply chain attacker can intervene and inject malware into a distributed package, distributed software artifact. So the attacker can jump in at the source code stage, can jump in at the build stage, can jump in at the stage where you pull in dependencies, so that actually there's also kind of like a recursive element to all this because upstream libraries can also be attacked at all these different stages, and they can jump in at the distribution stage. So for example, taking over your releases page. And there's other various points there too. When software moves from one stage to the other, that's also a point of attack. And then CI/CD and so on can also be targets, okay? So switching gears now to, we're going to talk, and sorry, one other mention is that some of us are, we're all consumers probably of Python packages, and many of us are producers of Python packages or other software. We have end users, okay? So supply chains are unique in that you have to look both upstream and downstream. So when you produce software for others, you can't just worry about your application code, unfortunately, in terms of security. You also have to worry about the software you're ingesting, because your users will wind up, you could pass on any vulnerabilities of upstream software to downstream to your users. So we have a responsibility not just for our own application code, but also for the dependencies that we ingest. All right, so let's talk a little bit about incidents. Just to give a little bit of a flavor, and this is CSI, the two people hacking on the keyboard or whatever. So that's how you defend, you type really fast. But in the case of, so just to give a little flavor here, and these are all fairly minor incidents, or mostly fairly minor, but they're kind of happening at this monthly cadence or even weekly cadence in some cases. And we have a very robust community here. People report that these bad packages are on PyPI. They get removed. Sometimes they manage to stay up for a little bit longer, but often they get removed pretty quickly. So I don't want to overstate things here, but just to give an idea of what PyPI has to deal with. And that is, in January, there was a cross public package index attack on both NPM and PyPI. In February, I put a little Napster icon there, but there was this kind of shady music kind of stealing central command and control package that was discovered. In March, we had these malicious utilities that they were pretending to be time utilities, but actually they steal people's cloud credentials. In April, there was something called an attack called Confused Composer, which I think is a cool name for an attack. We have a little Confused Amadeus or whatever there. And then finally, just this month, there was an attack where Gmail was used to exfiltrate information and credentials to try to avoid some like blacklisting, whitelisting. So Srishti is going to go into we're going to talk about two larger attacks that are more serious, and Srishti is going to talk about PyTorch.
Thank you. Yeah. So there's a good chance a lot of you here are already familiar with this incident, but I just would like to revisit this briefly. So in the December of 2022, around the holiday season, PyTorch's nightly rebuilds for Linux, especially for the ones which were pulled in via pip, it had a call for a dependency called Torch Triton. So the way this whole build was set up was that there was a extra index URL, which was supposed to be pulling in artifacts from an internal PyPI registry, which contain all the other build dependencies as well. Now, as most of you who are familiar with pip know, pip allows for this default behavior wherein if there is a newer version of a dependency available in the global index, it sort of falls back to it, and that's exactly what happened here. But the issue is that the exact name of this dependency, Torch Triton, was not reserved by the actual project maintainers. A malicious actor instead, replaced this in here. So when on examining this particular Torch Triton dependency, it was mostly the same. It had similar functionality, similar code layout, almost identical files, and it should have been okay. But on closer examination, there were a couple of changes in there. So one primary thing was there was a native binary called Torch Triton that was dropped in their runtime folder. And the init file that was there in this whole malicious package, it invoked this Torch Triton binary when it was being imported, and it harvested critical data like contents of etc password, SSH keys, and environment variables, and a whole bunch of these things, and transmitted this data over DNS to bad actors, essentially. Now, this whole thing sort of got contained within a week, and all the pip releases, especially the nightly releases, between Christmas and New Year were deemed vulnerable. The stable release users were not impacted by this, but there was still a significant chunk of users who were impacted by this dependency confusion attack. So, in terms of remediating this, they pulled this package out of pip. They cleared the pip cache and also published instructions as to how to get rid of these shady packages. They even went so far as to change the name of the internal dependency from just Torch Triton to PyTorch Triton, and reserve the name for both of these packages in the global index. So basically, they just made sure that across all namespaces, this incident would never occur again. So now that we're here in 2025 and we look at this incident in retrospect, I think there are a couple of lessons for us in there. One is maybe the usage of S-bombs that told you what exactly is in the things that you're fetching would probably give you a better idea of the things that are running in an environment. And in addition to this, maybe using hashed pin dependencies will confirm to you that the things that you want and the things that you have are essentially the same, and that there's no drift in there. If you're using repository managers, it's also possible for you to whitelist certain packages to be installed in your system. And I mean, even if you're going to be using pip, pip's amazing. I love pip. And there's a whole lot of flags that you could use to safeguard your environment. You can use extra index URL versus the index URL to be explicit about where your things should be coming from. Instead of fetching all your dependencies from, I don't know, the world, you could opt for manual installation of some of these dependencies, especially when you're not sure of where they're coming from. You can also whitelist certain repositories by using trusted hosts, and allow only trusted sites to kind of leverage to push in their packages into your system. So these are basically some of I think solutions which are already existing in place right now to make your build setup a whole lot safer.
Cool, thank you. See if I can find where the button is again. There we go. We also have Mr. Confused Guy who's confused about index URL here. So I'm going to talk very briefly about one other attack that just happened in December, and that is this Ultralytics YOLO attack. So YOLO, it's a fast object detection algorithm, machine learning algorithm. The Ultralytics implementation, which was hosted on PyPI, they experienced a supply chain attack where their GitHub actions were compromised. and the attacker was able to push out some bad distributions. And subsequently, they also leveraged the attack to get a hold of a long-lived API token, which allowed them to push out a second bad package. Ultralytics itself is in something, according to cloud researchers, is available in something like 10% of cloud deployments. So there's definitely some fallout from this. And the Ultralytics project did use PyPI's trusted publishing, which we'll talk a little bit more about in a sec. So they were able to, the attack could have actually been worse, and they were able to sort of follow along after the fact and see exactly what actions the attacker took. And also, the trusted publishing is sort of there to obviate the need for long-lived API tokens. So, so in theory, trusted publishing could have sort of made it so that they didn't need to have an API token available. So PyPI has actually been doing a lot in this space, and I just want to highlight some of the things that the PyPI maintainers have been doing, and then we'll move on and we'll talk about a few additional things that you can all do as maintainers, as consumers. So PyPI has implemented, like I was talking about, trusted publishing. It basically allows the use of GitHub as an identity provider or other identity providers in place of these long-lived API tokens, which can actually, once they leak, they can be very bad from a supply chain security perspective. They also have a PyPI GitHub action workflow. Just this year, they've instituted a quarantine process, a archiving process for old projects, which is actually very useful for this kind of thing. And there's been this big push toward using two-factor authentication for contributors and giving out physical security keys, which I think is pushing the ecosystem in the right direction. And one cool thing is, I think it's in beta now, but there's a reporting API for trusted reporters to be able to automate pointing out bad packages and so on that are appearing on PyPI. So what else can you do? So some of you are probably familiar with this, but we have a CVE system where vulnerabilities are known. They're put in a database, and then we can use scanners, such as Smyth, Gripe, and Trivy, to scan software artifacts and see if there are any known vulnerabilities in them. And I think as maintainers, if you're looking at upstream, if you're pulling things in from upstream, it's great to scan to get this into your CI/CD workflow. It's great to scan those dependencies and see, what do they have? Do they have criticals, highs, and see what you're passing on to your users. There's also another project called Salsa, delicious salsa. It's supply chain levels for software artifacts. This is a framework for supply chain security, and it comes in different levels, so you can kind of start at an earlier level, which I think is a great way of conceiving of it, because you can kind of dip your toe in and then over the course of years kind of level up. And it pushes, one of the things that it really encourages and pushes is this idea of signing your software artifacts and adding provenance information to them. And that kind of is a game changer. So it tells folks who use your software, it was built on this day under this technical environment by me, by whatever my organization is. And then that when they ingest it, they can check that data and see if there's anything surprising. So sign your software artifacts. That's from Darkest Dungeon, which is a pretty creepy game. Okay, so we want to talk briefly about something that we've kind of been thinking about in this space, and we've just released in EA this last week, and that is chain-guard libraries for Python. We started actually with Java, and one thing is our users have kind of come to us. We're mainly or historically have been a secure container images company, and our users, they use our container images as a basis to build their projects or their infrastructure, and but then they start adding ecosystem packages on top of that, and they're like, could you think of something, do something to do a similar sort of intervention in that layer? And so what we've thought of is chain-guard libraries for Python, and essentially what it is we take source, we ingest it into our chain-guard factory, and Srishti is going to go in detail about what the chain-guard factory is, and we build it, and then we pass it on in an alternative index to our users, okay? And now if there's a problem in the supply chain in terms of the source, we don't do anything with the source right now for various reasons. However, any of the other steps that I outlined in terms of build, distribution, moving from one stage to the other, and pulling in dependencies, because we try to go all the way up the dependency graph, that is secured by us by building in this chain guard factory. And so for attacks like Ultralytics, if you had been using this alternative index, you would not have been affected as a user. And so Srishti is going to talk a little bit about our very cool chain guard factory.
Thank you. So at the heart of everything that we do at ChainGuard is a ChainGuard factory, which enables what we do at scale. So as its input, it takes the source code of different Python libraries and the hardened tool chains that we've built from source, and also the runtime dependencies. So we build all of this and in a protected environment that sort of prevents any unwelcome supply chain intrusions in a Salsa 2 hardened build environment. Again, as Patrick mentioned, when we say Salsa 2, it basically means that our builds run on a platform wherein we can generate and sign the provenance of the artifacts that we build. It basically assures software supply chain security in multiple places in that flowchart that we just reviewed. And there are also multiple points of attack in that flowchart that we saw. So other than the source in itself, we've found that the build and distribution stages are most susceptible to software supply chain attacks. And in order to address it, one of the approaches we've taken is we build everything from source. And this is pretty straightforward when we talk about pure Python libraries, because you build all of it. But for a good chunk of our projects, there is also native extensions, and in those cases as well, we build things from source. And it's kind of tricky there because we have these dependencies along with the native system, and the Python wheel that you build, it's very tightly coupled with the host OS. And when you try to use it across different systems, the developer is basically having this very delicate dance of satisfying all of the Python wheel's requirements. And in a number of cases, it's this extremely delicate balance, and people do not want to disturb it, and they do not want to upgrade their software, their libraries, and they try to kind of stay with what works for them. So it's been a huge sort of a discouraging factor for people to update to the latest and greatest and stay on the edge as the project moves further. So in terms of why people do this, there's a whole lot of reasons as to why somebody is utilizing these C or C++ extensions. They largely contribute to better performance and reasons like that. So the solution for most part has been to sort of ship these native extensions along with the Python wheels, and these vendor dependencies together have made these Python libraries like a mini OS that's sort of self-sustained and in no way impacts the developer experience. So there is truth there about how it's making the end user experience better, but by vendoring these dependencies, we are baking in unknown and untraceable binaries into Python wheels that have no metadata. So inadvertently, we are now pushing these unknown components for our downstream developers, and these are mostly untraceable, and we call them as software dark matter. So with software dark matter, the issue is that even with our SEA scanners, they remain largely untraceable and continue to remain in our environments, even if they happen to be nefarious. So in these cases, what we've done is we've isolated, identified, and rebuilt all of these vendor dependencies so that we are responsible for generating the provenance of these things and preventing supply chain attacks even in the software dark matter, so you can work on whatever it is that you do the best.
So we'll just move on to a couple of takeaways. And
Next slide.
sorry. Yeah, so if you are a maintainer, first, if you're not using trusted publishing, you should definitely use trusted publishing, and if possible, the GitHub workflow for PyPI. To take a little step back, if you're still building and uploading from your laptop and pushing it up, I would say now's the time to do that shifting left and maybe to externalize some of that to a CI/CD workflow, because it becomes a little hard to intervene in these ways if you don't have that kind of thing set up. Secondarily, you should consider signing your artifacts, okay, and using a project like SigStore. And then finally, if you're not scanning, scanning is a great way to evaluate upstream dependencies that you're pulling in. And otherwise, if you don't use these tools, it becomes very hard to do a manual review of your dependencies. Also, use fewer dependencies if possible. And then finally, if you're as a consumer, I would say you should think about more yellow flags than maybe we were thinking about a year or two ago, or even 3, 4, or 5 years ago. So if there's no source linked, just ask yourself why there might not be a source for one of your dependencies. In some cases, it's clear enough. In other cases, that may be something like a yellow flag. You may want to consider pushing projects that you're involved with towards signing their artifacts. Any or major projects that you're depending on, you could say, hey, open an issue. Say, could we sign, and have some salsa provenance in this so that we can check and make sure that things haven't been tampered with when we ingest these dependencies. And then if you're not, in some cases, if you have a little bit more of a complicated setup, like we were talking about with PyTorch, consider using a repository manager because that can really simplify that. Where am I pulling from and under what circumstances? So those include things like Artifactory. There's a lot of different offerings. There's Nexus, there's Cloudsmith. So you could look, there's many repository managers. You can pick one that works for you. Some of them run locally too, which is great. And I just wanted to give a thank you to PyPI because it's a critical part of the Python community. It's sustained Python for a long time. It's a modern infrastructure that has been doing a good job keeping up with all of this. And I think they've been moving the ecosystem in the right direction. So I think you can add on top of what PyPI is doing. They don't make it all their responsibility, but I do think that PyPI has been moving in the right direction for a long time. And I know some of this is pretty difficult, and there's been some difficult discussions, but I think the direction is the correct one. So if you're interested in ChainGuard libraries, we've got the QR code here. So I'll give a second to pull that up if you're interested or want to check it out. And by the way, that's Linky. He's our mascot at ChainGuard. He's the smallest. We like to do octopuses. We have one of our open source OS, Wolfie, is the smallest octopus in the world. And then if you want to connect with either Srishti or myself, Srishti is there on the right. I'm on the left. These QR codes, and you can see Wolfie going, the tiniest octopus in the world, going into his little hole there. And we have, I think, maybe a few minutes for Q&A, hopefully. Thank you.
Yeah, does anyone have any questions?
Do you have the walking around microphone?
I just have a question for you.
Yeah, go for it.
If you had one small thing that we should all be doing as Python developers to make our code and what we do more secure, what would that be?
Evaluate your dependencies, I guess. See, you pull in fewer dependencies. I think we're good at looking at our source, you know what I mean? Because that's right in front of us. It's in our VS Code. It's in our whatever, our Emacs. It's sitting right in front of us. So we're used to that. I think we know not to allow for SQL injection, in 2025. Generally speaking, it still happens. But in terms of when you pip install something, when you depend on something, it actually pulls in 10, 20, 50, 100 transitive dependencies. I don't think we've internalized that. So I think anything you can do to look upstream is going to be something that's going to be good for your end users. But that's a great question. Thank you. You have anything to add, Srishti?
No, thank you.
Cool. Well, great. Let's give them another round. Oh, you got a question? Okay.